So we start this old exam by looking at some nomenclature questions. And this one looks pretty straightforward at first. But one of the issues we find is when we look for the longest chain in this molecule. And the issue is we have 3 chains that all qualify at the same length. I've got one of them in black here, one in green, and we can put the last one here in purple. And it could then continue through any of the other directions. So the first thing we have to determine here is which one of these we should pick. And remember, the first thing that we use to distinguish between 2 chains of equal length is the one that has the most substituents. And if you compare these chains, it becomes clear that the chain that we first drew in, the one in black, has more substituents than any of the others. So we're going to go ahead and erase these so we can see this better. But we're talking about the chain that goes here. So we're dealing with an 8-carbon chain, which, as we know, we would name as an octane. Now, which direction are we going to number this in? Do we use the purple numbers, or should we use the green numbers? Well, the way we pick is we look at the direction that gives us a substituent closest to the end. If we use the purple numbers, our first substituent is on carbon number 2. However, if we use the green numbers, our first substituent is on carbon number 1. That's closer to the end, and so we're going to use the green numbers in this case. Our next step is to then name all of our substituents, and sometimes, especially if there's a lot of substituents, it just becomes easiest to start by making a list. So on the first carbon we have a bromine. On carbon 3 we have a methyl. That's right here, this 1 carbon group. And we also have a 2 carbon group, or an ethyl. At carbon 4 we have an isopropyl group. At carbon 5 is a propyl group. And then finally we have 3 chlorines at 6, a second one at 6, and a third one at 7. And so since there's 3, we make that trichloro. There's no other like substituents to have to combine, so at this point it's just a matter of writing out the name. So bromo comes first. What comes next? Well, remember, when we have something like trichloro, the tri is a numerical prefix. And when we alphabetize substituent names within a molecule, we ignore all numerical prefixes. So trichloro still gets alphabetized under the C for chloro. Then we go to 3-ethyl. What comes next then? So we still have methyl, isopropyl, and propyl. Well, iso is not a numerical prefix. And so anytime we have iso, whether it's isopropyl or isobutyl, that gets alphabetized under I, because again, iso is not numerical. So alphabetically, isopropyl comes next, followed by methyl, and finally propyl comes last. Now that we've named all the substituents, we just need the name of the parent chain. This chain is 8 carbons long, and so this is named as an octane. Here in part B, again, we've got a fairly complicated molecule, or at least one that looks bad. But it's going to be a lot of the same things that we saw in part A. We have several chains of the same length, but only one, the one that goes here, has the most substituents. And it has a total of 10 carbons. We could also number in the other direction. Like this. Now, are there other ways that we could also come up with 10 carbons? There are. We could have come this way. And we could also have come from this carbon and then continued up and to the right. But in either case, if we had used the carbons as the end of the chain that I've pointed at in red, we would have ended up with a chain that had less substituents overall. So the one that we've chosen has a total of 9 substituents. So these other two starting positions that I've indicated are also both 10 carbon chains. However, the first one, the one on the left, only has 7 substituents, and the one on the right has just 5 substituents. So we want the one that has the most substituents. So now that we've done that, we can start to name our substituents. So we've got a whole bunch of methyl groups. We have one at carbon 2. We have another one at carbon 2. We have one at carbon 4. 2 of them at carbon 7, and 1 at carbon 8. So a total of 6 methyl groups. Now I skipped over a step, so let me go back and pick that up. Why did we use the green numbers here instead of the purple numbers? Again, it's where the first substituent occurs. So going by our green numbers, our first substituent is on the second carbon. With the purple numbers, our first substituent is on the third carbon, and so as with the previous example, we use the green numbers. So we've identified the methyl groups. What else do we have? So we have another substituent at 4, we have a substituent at 5, and a substituent at 6. I'm actually going to remove the purple numbers just so there's no ambiguity here. At carbon 4, we have a 4-carbon substituent, but it's not a straight chain butyl group like we have at carbon 5. So carbon 5 is 4 consecutive carbons in a straight line. That makes it a butyl group. But carbons 4 and 6 are also butyl groups, but different arrangements. And so these are some of those non-standard substituents that you just have to know. So carbon 4 is an isobutyl group, and carbon 6 is the tert butyl group. All right, so let's write out the name. What comes first? Well, we know we start with butyl. Now, tert butyl, tert or tertiary, is a numerical term, so that also gets alphabetized under B. We usually put it after butyl, but it is alphabetized under B. That's different from isobutyl, which, as in the last problem, is like isopropyl. Iso is not numerical, and so we alphabetize that under I. Then we put in all of our methyl groups. There's 6 of them, so we indicate that by hexamethyl. Again, hexa is the numerical prefix, so methyl still gets alphabetized under M. And then finally, it's a 10 carbon chain, so we put in the parent name of decane.